Alright, so we just learned about arithmetic sequences and their sums. So now we're going to talk about geometric sequences, which is another specific type of sequence. You have already worked with these in 13.1 and 13.2, but now we're revisiting it and we're giving you an actual formula for it. Alright, so this first part here is really just review. It's the first 5 terms of each sequence. So again, you're going to try this one on your own, but we're going to do this one together. So here we go. We've got an equals negative 3 to the n plus 1. So we need first 5 terms. I need a1, a2, a3, a4, and a5. Well, now let's plug in some things. I need to put the 1 where the n is. So negative 3, since there's parentheses, I'm going to use parentheses this time. If there weren't, like on this one, you don't need them. Though in your calculator, make sure that this is entered in parentheses, the negative n. Alright, anyway, going back. 1 plus 1. Negative 3 to the 2 plus 1. Negative 3 to the 3 plus 1. Negative 3 to the 4 plus 1. And negative 3 to the 5 plus 1. Oh, yep. Alright, simplify. Negative 3 squared. Negative 3 to the 3rd power. Negative 3 to the 4th power. Negative 3 to the 5th power. And negative 3 to the 6th power. Now, either you know how to do these in your head, or you have to use a calculator. Majority of you probably should use the calculator. Negative 3 squared, negative times a negative gives me a positive 9. Negative 3 cubed, a negative times a negative times a negative will still be negative. It's going to be negative 27. Negative 3 to the 4th, well, that's going to end up being positive. We're going to take that to the power and get it 81. Negative 3 to the 5th power is going to be negative 243. Negative 3 to the 6th power will be positive 729. Alright, found those terms. You want to list those out. Again, make sure you try this one on your own. Now let's talk about a little bit of vocab here. So, first thing, sequences that are above these two are geometric. How do I know that? Because we are multiplying or dividing by the same amount to get to the next term. So notice, to get to the next term, I multiply by 3. Well, negative 3. To get to this term, I'm going to multiply by negative 3 again. To get here, I'm multiplying by negative 3 again. To get here, I'm multiplying by negative 3 as well. So that's what I'm talking about. We're multiplying, and then in this example, you're going to realize some division. Alright, so what exactly is a geometric sequence? It is every term but the first term is formed by multiplying or dividing by a fixed amount. Again, that fixed amount, tying it back here, that fixed amount is your negative 3. Alright, so moving on to the next thing. What else do we need? We identify it by noticing that we multiply, or again, divide, the same amount each time. Another thing is we must, absolutely must, have or be a variable exponent. So there has to be a variable exponent in order to be geometric. So, what is this fixed amount? The fixed amount is your common ratio, which we call R. So a fixed amount that the sequence is multiplied by to get to the next term. Right? Important part here is it can be positive or negative, either one. And it can be an integer or a fraction. This is when you are dividing. So that is when we use fractions. Alright, so that's all kind of the components of it. Now let's actually apply it. So what is the formula for a geometric sequence? So a geometric. Well, the geometric sequence is an equals a1 times r raised to the power n minus 1, where an is the nth term in the sequence, so whatever term you pick, n is 2, that's the second term, n is 5, it's the fifth term. A1 is the first term, r is your common ratio, and finally, n is the number of the term. Alright, so let's go and put this in the steps to writing one. So you've seen some of these again. We're going to go and make the steps now. First thing is you want to identify the parts of the sequence. So an stays variable to create the formula. So whatever an is, it just stays. A1, first term in the sequence. So a1 is 25. Well, now we got to think about how do I get to the next term, and then the next term, and then the next term. Well, in this case, it looks like I'm dividing by 5 each time. So dividing by 5 really means that I am multiplying by 1/5. So I have a common ratio of 1/5 here. So now I've identified those two parts, and again is going to stay the variable to make the formula. So now I'm ready to do the next step. I've identified the parts, now I need to substitute into the general formula. So an equals a1 times r to the n minus 1. So an, again, stays the same. A1 is 25 times r, which is 1/5, to the n minus 1. And this, right here, is our formula. So now let's write one more. Alright, so first, identify the parts of the sequence. So a1 equals 4. And let's figure out what's going on here. So to get to the next term, how do I get there? Notice we have alternating here. This means we need a negative term. So 4 times what gives us 12? 3 times 3 times 3. But again, I need a negative 3, because each time it is going to become negative, positive, negative, positive. So r equals negative 3. Alright, now into our formula. an equals a1 r to the n minus 1. So an equals a1, which is 4, times r, negative 3, to the n minus 1. So again, I have created my general formula. So now that we know kind of how to do those general formulas, this kind of will probably seem like, oh, why didn't I have this sooner? Well, again, we need to build your knowledge to get to this point. So again, try this one on your own, and then move on to the next sheet, because we have 2 more types of things. So what happens if we have to find the requested term? So finding the requested term or value means first we need to find a formula. So for example 5 here, if I want to find the first term, that's a1. I don't know what that is. Of a geometric, so I know that's an equals a1 times r to the n minus 1. If I'm given the 7th term, so n equals 7, and that term, a7, is 1/16. And then it tells me the common ratio is 1/4, so r equals 1/4. Well, I need to plug this all in to find it, otherwise I won't be able to do anything. So an equals a1 times r to the n minus 1. Now fill in your parts. So I know a7, so that's my an, 1/16, equals, I don't know a1, that's what I'm trying to find here. So I have a1 here. I know r, that's 1/4. And I know n is 7 because that's the term I used. So now let's figure this out. Let's simplify it. 1/16 equals a1 1/4 to the 6th power. Well, what does that equal? Put it in your calculator. Figure it out. 1/16 equals a1 1 over, now leave this as a fraction, otherwise it'll make things a little bit difficult. Well, how do I get rid of fractions? Multiply by the denominator. So if I multiply by the denominator, I end up with a equals, so those cancel, 256. So the first term is 256. Alright, what about finding r? So find r, so I don't know r. Geometric sequence, again, an equals a1 times r to the n minus 1. If a1 equals 3 and a5 equals 1875, which means n is going to be 5. So take our general formula, an equals a1 r to the n minus 1, and fill in what we know. An is 1875, a1 is 3, r we don't know, n is 5, so fill it in. Well, this I can divide by 3 to get rid of the 3. So now I'm left with 625 equals r, 5 minus 1 is 4. Now we're going back and trying to figure out, oh, well, look at this. How do I solve this? I need to take the 4th root all the way back to last chapter. Not last chapter, sorry, last semester. So r ends up equaling 5. So the common ratio is 5. Alright, and again, here is your try on your own part, 7 and 8. One of them is going to be finding a term, the other one is going to be finding R. So this one is just like kind of this one up here. This one's a little bit different than that one, because I gave you A1 and the ratio. Alright, so you do that, come and bring it to class tomorrow.